In this session, we are going to stress the system, but intelligently. Hopefully, it will not crash, but to observe how OS protect itself. Now, my system has 8 GB RAM. If I see free dash H output, currently only approximately 1 GB is free. So we must behave like good engineers now in a controlled experimentation. So like what we did was we executed free dash H. So look carefully here. The memory, it shows 6.7 G, used around 3, free somewhere around 970 M, correct? And rest is cache and buffer. So practically, we do not have full 8 GB available, correct? Then when we fire htop, even though memory seems partially free, like you can check here, correct? So memory seems to be like this much is used and it is showing us. Linux is already using it efficiently. There is no swap included and so on. So important concept here is like free memory doesn't mean it is available memory. Linux uses RAM for caching to improve the performance, but it can reclaim it when needed. So let us try to load with small control load on our system. Fine. So we'll try to see like if we can create some process with the load like this. So let me use stress command again. Stress. So when I use stress, ultimately it is used for trace testing. So let us check one more time. What is the scenario? So we have around this, correct? Approximately this would change because applications are running in background. So let us see. Approximately we are getting around 800 to 900 MB, correct? So let us try doing this. Stress dash VM. I will create one process with VM bytes to be say 500 M. Okay, and then we'll give timeout. Okay, within the safe range. So let us say I'm giving timeout of 40 seconds. Now we are having only one process and we want it to use 600 MB, correct? And let us see like what happens. Sorry. So dash, I should have used space here. Stress dash dash VM dash dash STRESS dash dash VM. This is dash dash VM. Yes, my mistake. So when I write this, ultimately one can see it started the work. Now how to monitor this? So let me open another terminal from here. And now let me see output of this command. Watch dash N1 free dash H. It is showing us this like how much used, how much free. Correct? You can see the changes that are happening. Available is also there. Correct? Available doesn't mean free. That's what we said. Now, if we see this free memory, it is getting modified subsequently. And the program got completed. So that's why you can see this. Now let me increase this 600 MB and let us check it again. You can see the changes that are happening, used and free. Correct? Let us see what happens like when it reaches to free. So we have given 40-second cycle. So that will change, available is changing. Correct? So if we observe something here, like free memory sometimes reduces, cache reduces. Correct? System adjusts smoothly, no lag, no crash right now. So before using swap, what Linux does, so if you see now, it completed in 40 seconds. Again, Free is there. So before using swap, Linux first frees the cache, reclaims buffers, and then considers swapping. So swap is the last resort, not the first action. So can we do something more? Let us try doing so. We'll try to have now two processes with 600 MB of the storage. Right? 600 plus 600, that means it would be around 1.2 GB. Safe, but it would be tight. Let us see how it responds. Now you can check free. Available is also adjusted with the 40-second cycle. When G is free, it hasn't used swap space yet. Will increase later. Like once that this 40-second cycle limit overs, now you will see like the machine is not responding. Sometimes it is stopping. Right? You can really check that. Fine. Let me do this one more time. Now I will increase this to 800 MB. You can see swap space it used now. Correct? It started using swap space. Now if you see, we are very close to memory limits. Watch carefully. As swap starts slightly, that is paging. That's where your paging came into picture. It actually used 1 MB. Correct? You can see this. Like when we had stress to be of 1.6. So if we increase that again, probably it would be more. Now once it is done, let us see like what happens. So let me rerun. Now you can see the what it is showing us, swapping activity slowly happening. Correct. So if I write now swap on, you can see it did with partition. It used 1.5 MB. Correct. Though the swap size 8.4 gigabytes, which is using this SDF5 partition. Correct. Now, similarly, if I see vmstat output, you can see like if there has been some swapping. Right now, nothing is done because no other program is running. It is just showing the swapped and free memory. Okay, swapping does not hold currently because there is no swapping going on. Fine. Okay, so let us go back and let us fire that command again from here. Fine, and then let us check this swap on show. It is showing this. Now if I show this one, you can see usage like depending upon when it reaches to that extreme level of memory usage. Right now free is there. So it is adjusting the pages. Now the work is done. So if I write now this, nothing is there. Correct. Let us go back and execute this one more time. And let us fire vmstat here. We'll see like whether it makes use of some swapping there. It is not showing yet anything, correct? Even if I check with that free dash h, you can see the swap in and swap out is like the program must have completed now. Yeah, it will complete after a while. If you see, it is still showing us 000 vmstat output. Correct? It is zero, just zero. Swap in, swap out. Nothing is done. Correct? Because the program must have finished right now. Now let me put one more load. Now, now I will have 3. Correct? Now let us check here first. So we'll stop this and then we'll check watch. And now small values actually true here. Like when we said, when we see and swap 1.0 MB, ultimately, actually paging has happened. Correct? System is still responsive. Why? Because it is showing us the details. Correct? Even like if I check it here, or maybe the command with vmstat 1. Right now, nothing is happening because it must be adjusting the task. Program completed. So let us say this to be 60 seconds. Now again, the work started. So check with available, free, and used. 1 MB is very negligible if you see carefully. Correct? The program is still running. No swap in, swap out. So free somewhere is now in MBs. Okay. We can move or put more stress and exactly check what is happening if at all you wish to try. Correct. Now, if you see carefully here, the system is still responsive because we increased the memory gradually, stayed with safe limits, and avoided overload. Now, if I run something like 3 GB or 4 GB processes, then ultimately problem may start. This system will start heavy swapping. It will become slow and possibly it will freeze. So maybe like I should say that don't try this at home, but let me see like if I can try. So let me write 1.5 G. Let us see what happens. Now you can see heavy paging started. Probably my system may enter into non-responsive mode. Correct? You can see now 59 MB actually is used for swapping purposes. Correct? Here, even if I see this case, you can see the paging. Swap in, swap out is happening 48.0. Correct? That means definitely some swapping is happening. So now my system probably may enter into slow mode. It is, you can see the mouse movement that is happening. Correct? Or the pointer movement that is happening. It is bit slow than what it should be. Now, sometimes what can happen is, like if I increase that 1.5 to 2 or maybe 3 or maybe 4, that would be thrashing. Correct? That will demonstrate the thrashing issue. Now you can see after some time it will cool down. Correct? Cool down the usage. Now, if I check with this sad cat /proc /sys/vm /swappiness. Here it showed us some number. Now, rower value means like 60, it is preferring RAM. And if this value is very high, that means more swapping. Correct? Now we can control multiple parameters. So if at all we have to kill, so what I will do is I will kill all stress. So Strace probably completed its execution, so nothing is there. So if I write free-h, you can definitely try this. It will show you this usage. Correct. The memory returns, like you can see again, 3 GB is available. System stabilizes. Swap may still have some idea, and that's normal, which you see here, 59 MB. So today, what we observed, something very important. Even with limited free memory, system did not crash. System adapted, system optimized. And this is power of paging plus swapping plus smart memory management. So a good engineer does not just run the experiments. They design experiments that do not break the system. So safe rule for your machine is never exceed 70 to 75% of available memory. With 1.5 GB free, keep stress less than equal to 1.2 GB in total. So we did not overload the system. We guided it into the pressure and watched it responding intelligently. And that's what exactly you can really see how memory management is done, or how virtual memory and swapping is done internally. Thank you.